Hello, everyone. Welcome to the first step of the TERA process under ISO SAE 21434 item definition. TERA stands for Threat Analysis and Risk Assessment. Before we can analyze threats or evaluate risks, we first need to clearly define what we are protecting. This is what we call the item. In this training, we'll look at a real-world example using an ADAS ADCU, the Autonomous Driving Control Unit. Let's get started. This diagram shows our item, the ADAS ADCU, or Advanced Driver Assistance System Autonomous Driving Control Unit. It processes environmental data collected by in-vehicle sensors and provides both driver assistance and autonomous driving functions. The blue dashed box indicates the item boundary. Everything inside the boundary, the ADCU itself, is what we'll assess for cybersecurity. Everything outside sensors, servers, gateways is considered part of the operating environment. Clearly defining the item helps us understand where our cybersecurity responsibilities begin and end. Now let's take a closer look inside the ADCU. It consists of 5 main software components. Sensor Fusion Manager. This combines data from multiple sensors to create a complete picture of the surrounding environment. Path Planning Manager. Based on this picture, it calculates where the vehicle should go. Control Manager. It translates plans into control commands for steering, speed, and braking. Diagnostic Manager constantly monitors the health of the system and manages diagnostics. Update Manager handles firmware updates via over-the-air OTA communication. Defining each component makes it easier to later identify which parts might be vulnerable to cybersecurity threats. Now let's look at what surrounds the ADCU, its operation environment. Radar sensor detects vehicles or objects in front of the car. Camera sensor recognizes lanes, road signs, and traffic lights. LiDAR sensor builds a 3D map of the surroundings. Backend server manages vehicle status remotely and provides software updates. Gateway CGW routes data between the ADCU and other ECUs inside the vehicle. Understanding the environment is key to recognizing where threats may come from. Here we summarize the major software functions of the ADCU using function IDs. FCO1 object detection using sensor fusion to recognize obstacles. FCO2 route calculation, planning a safe route based on the current situation. FCO3 vehicle control, executing actions like acceleration, steering, and braking. FCO4 firmware update, updating the system software via OTA. These functions give us a structured way to later trace threats or security requirements back to a specific part of the system. Next, let's look at the interfaces, the communication paths between the ADCU and its surroundings. IF01 CAN network used to exchange sensor data within the vehicle. IF02 Ethernet enables high-speed data transmission inside the car. IF03 LTE 5G connects the ADCU to external systems like the backend server. Each interface could become a possible attack path, so identifying them early is crucial. This table summarizes the environment we saw earlier. It lists each external element and its role. For example, the radar sensor is essential for forward object detection. If it fails or is tampered with, serious consequences could follow. This table is especially useful when we assign values to cybersecurity assets later. Finally, we define our assumptions. These are conditions we consider to be true while performing TERA. First, we assume the backend server is securely managed by the OEM. Second, we assume the in-vehicle sensors operate correctly and provide accurate data. Third, we assume OTA updates only occur through authenticated, trusted channels. But if any of these assumptions prove false, we may need to go back and redo our TERA. That's why documenting assumptions is so important. They directly affect risk decisions.